Okay, so the quiz number one. So quiz number three. This was a quiz for number three. So make sure you take down these notes and take down how to solve these equations, because you will in the future you will see this on sometime it's on your final exam. So you want to know how to do it. So this is I'm working on the problem and show you how to do it. So make sure you take notes, good notes, and that will help you. Okay. So the first one here, number one, they want the total resistance of the circuit. So this is a series circuit. You got R1, R2, and R3. So a series circuit, you just add the total together. So that's is my formula. R total equals quantity R1 plus R2 plus R3. Okay. So I just substitute that. So R1 is 100 ohms, R2 is 1000 or 1K. So I convert that one to the base unit, 1000 ohm, because the answer is they want in ohm. So I want to make sure that everything in ohm, so I can add them together. So that's 100 plus 1000 plus 1500. So the answer is 2600 ohms. So I think that everybody got this one correct on the quizzes. So congratulations, that was pretty good. Okay. So the next one, the one total, so this is number two, total current. So total current equal E divided by R total, okay? E, it's the 12 volt, the voltage source is 12 volt, divided by the total resistance of 2600 ohms. So that's giving you 0.0046 amps. And you convert that one, the answer they want in milliamps. So that's why it's going to 4.6 milliamps. Okay, so that's why you got 4.6 milliamps. Okay, the next thing you want to do is the one solve whatever at the point at VC, okay? VC, so VC is the same thing as like we said, Ohm's law. It's going to be current times the resistance. So this one is the current times the resistance, okay? So the current, we only have one current available, so which is the total current. And resistance that it had to travel through from point C is going to be R2 and R3. So that's why you have to combine R2 and R3 together, okay? So you got a 4.6 milliamps times quantity 1K plus 1.5K, and you take that, add it together, and multiply this, you should get about 11, and then multiply it, and it should get 11.5 volt. So number three should be 11.5 volt. So is any question? Everybody follow? Okay, all right, next one. Okay, so this one is the next one. Okay, so this one, now this one is going to give you this one is a series circuit too, but it's going to be missing R4. They don't know, they don't know what the R4 is. So we're going to you're only given a certain amount of information. So you're going to use that to solve the equation, okay? So you're given that power at R3 is 100 milliwatt, okay? So that's P3 equals I squared times R3. And so we're going to have to solve this equation first. So therefore we can say I squared equals P3 divided by R3. And so now we just solve for the I itself. So I is equal to so this is I would be total current. So you get one I, okay? So I is the square root of P3 divided by R3. So here it is, the formula that I modified from this original. So now we got this one here. So it's going to be I total equals the square root of P divided by R3. So square root of 100 milliwatt divided by 1 kilo ohm, which is R3. Okay, you saw that. So this one is going to be, so that's 0.1. So convert this one to the base unit and this one to the base. So that's divided by that. Okay, and take the square root. So that should become to 0.01 amp, and they want the answer to be in milliamp. So therefore, we're going to be moving the decimal places to the right 3 times, or time 1000. So it becomes 10 milliamps. So the answer here for number 2.1 is going to be 10 milliamps. Okay. All right. So any question on that one? Everybody follow? Okay, so the next one we want to do is find the R total. Okay, R total, we know the R total equals E divided by I total. Okay, we know E, which is 130 volt, and we know I total from the 2.1, which is 10 milliamps, okay, or 0.1. Okay, so It's going to be 130 volt divided by 0.01 amps. Okay, so you divide that and you give you 13,000 ohms, and then you convert that one over because they want the answer in kilo ohm. So it's going to be 13 kilo ohm. Okay, so the R total is 13 kilo ohm. Okay, now that we have the R total, now we can solve for what the R4, what the value of R4 is. So R4 is going to be the R total, so the total resistance of this circuit minus all the known resistance. So minus the R1, my R2, R3. So that's why you combine all of them here. So 13K minus the quantity of R1, R2, and R3. Okay. So 13K minus the quantity 3K plus 4K plus 1K, that come up to 5K. Okay. 5K is R4. Okay. Okay, Oscar, do you have a question or? No?
I wanted to say that I'm here. It's just I had a bad Wi-Fi connection. That's all.
Okay, thank you. Okay, yeah, just kind of keep up. You can go back and watch the video. I covered this exercise, okay?
Okay, for sure.
All right. So, okay, so anybody have any question about this or everybody okay?
Okay.
Okay, yeah, if you have any question, if anything is not clear, please bring it up because we want to make sure that you understand this. All right, so next one. Okay, so this is represent, okay, so next one is look like also a series circuit. Series circuit, so they wanted to find the total current. Okay, so let me see if the chat, so, okay, so, okay, all right, so, okay, so this is a total current, the one total current, okay, and they want the answer in amp, okay. So first, so this one is only so therefore, we don't know the voltage source. We don't know how much is coming in, but they already give us the voltage drop over R2. So we're going to use that to calculate the current, okay? So I total equals to VR2 divided by R2. So which equal to VR2 is 4 volt divided by 100 ohms. So that's give you 0.04 amps, okay? So now we know the total current, okay? So total current we know is 0.04 amps, okay? So now we know this one to find the next voltage drop over R1. So therefore, we're going I total times R1. So I total is 0.04 amps times 300 ohms. So that's go to 12 volt, okay? So VR1 is 12 volt. Okay, now we can use find VR3. So we need to find the voltage drop over VR3. So VR3 equals I total times R3, which is equals 0.04 amps times 250 ohms. That gives you 10 volt. Okay, so now we can use it to find the voltage source, how much was actually goes into the circuit by adding all the voltage drop over each location. So VR1 plus VR2 plus VR3. So therefore VR1 was 12 volt, VR2 was 4 volt, VR3 is 10 volt. So you add that up together, and that's give you 26 volt, okay? So the 3.4, so the answer at VAB, it should be 26 volt. Okay, so anybody have any question?
No.
Okay, so next one. Okay, so next one is, okay, so this is look like, and these two is going to be a parallel circuit. So figure A is parallel, figure B is parallel. Okay, so so for number 4, they want to solve for RT of the first one. Okay, so RT, you can put in your entire formula. So R total equals 1 divided by the quantity 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And so you substitute that in. So that's going to be 1, do that. And so now we have to do is find all the common denominator of this, which is 1800. So therefore the first one is 1 over 180. Next one is going to be 2 over 180. This one is going to be 3 over 180. This one will be 3 over 180. So we're going to add the numerator together and the denominator stays the same. So therefore it's 1 plus 2 plus 3 plus 3. So that's going to be 6, 8, 9. So that's going to be 1 divided by the quantity 9 over 18, 180 ohms. So, and then this one represent inverting. So therefore we move this 180 to the numerator, and moving the 9 to the denominator. So 180 ohms divided by 9, it's going to be 20 ohm. Okay, so 20 ohms is the total resistance of this circuit right here. Okay, any question? No? Okay. Okay. So number five, okay, so we're going to be finding the current I1. So I1 equals I total times R2 divided by the quantity R1 plus R2, the total resistance. Okay, so this is represent a ratio of how much current will be flowing through the I1. Okay, so it's going to be 20 milliamps, the total that's coming in, times 200 divided by the quantity 300 plus 200. Okay, you put this one into your calculator and the answer should become to 8 milliamps for 5.1. Okay, and I2 equals I total times R times the quantity times R1 divided by the quantity R1 plus R2. Do that the same thing. That should come to a total of 12 milliamps. Okay, and then you add them together. This one plus this one should come up to the total that we put into the circuit, which is 20 milliamps. Okay, so 12 plus 8, total of 20. So therefore, that is correct. Okay, so I1 is 8 milliamps. I2 is 12 milliamps. So any
Basic
question?
current divider rule.
Yeah, well, this is the current divider rule.
Right.
I1, I2, same formula.
Excuse me?
I1, I2, we use the same formula.
It's the same formula. It's just that whatever you look at. So when you look at the I1, you're going to use R2. When you use I2, you're going to focus on R1.
Oh,
Okay. Because which one more current would be flowing through R1 or R2? Okay. It's going to be flowing more. That's going to be flowing to R2 because this one is a small resistant.
Current takes the
So that's
path
why
of
we got
least
this one.
resistance.
okay. Thank you.
Okay.
Current
So
takes
any
the
other
path
question?
of least resistance.
Okay, so that covers that. Okay, look like a few more students that just comes into this class. So okay, so we're gonna be trying to get the student to sign up for the lab full. Look like I see the look like Oscar. Let me see, Oscar. What's your last name, Oscar? Are you still here? Oscar, what is your last name? Oscar, can you hear me? You can type in the chat.
Yeah,
if you,
hi.
Okay, what is your last name? Oscar. I'm just using your first name for now. Okay. Now this is the time when we open up the lab, which is probably until September in the fall. Okay. So we have to assign students to work in a lab station that doing the hands-on training. Okay. So what time schedule would be ideal for you? 2:30 to 5:30 or 5:30 to 8:30? Okay.
5:30.
Okay, 5:30 to 8:30. Okay, thank you. Okay, so we're gonna be, let me see, that is gonna be 18. Okay, so X here. Okay, so this is Moreno. Okay. All right, so the other one that I saw was Jean. Jan, let's see, Jean. Okay, so Jan.
Here I am.
Okay, Morales. Okay, Morales. Okay, Morales. Okay, Jan Morales. All right, Jan.
I got the dates wrong. I thought today was Tuesday.
Okay, so now we have we're going to schedule the for lab that is going to be coming in September. So we want to plan ahead so that way we know how many students will be in the lab. Okay, we have a scheduled time. It's going to be 2:30 to 5:30, or would you prefer 5:30 to 8:30? Which one would be more ideal for you?
I'm just gonna say 5:30 to. Wait, what's this about?
This is a lab where you can have to go into the lab station to work on the lab to do the hands-on training.
Maybe I'll try 5:30 to 8:30.
Okay, thank you. Okay, So it look like Mirites. Okay, so we got Mirites. Okay, so Valencia. Okay, okay, so gonna be right here. Okay, so you're gonna 3 to 5:30. Okay. Okay, look like you got your license. Yes, a fee for the lab. No, the lab is going to be just similar lab like Mr. Ty's been showing you, but you're the one that's going to be doing the lab. Okay, Mr. Ty is not going to do the lab, so you're going to do exactly similar to what Mr. Ty is doing. He's been trying to show you on his. Okay. Let me see. Okay, Gerardo Moreno. Okay, Gerardo Moreno is right here, 5:30 to 8:30. Okay, thank you very much. Okay. Okay, so anybody else I missed? Please go ahead and type in the chat, and so I can fill up this sheet, and so that way I can return it to Mr. Pham as soon as possible, so that way we can help plan out where you're gonna be in the lab. And okay. Thank you very much. We'll go back to Mr. Pham. Thank you, Mr. Pham.
Did you done for the review?
Yes, with the quiz is done, and I already went over the homework assignment that they were having question about, and also to sign up for them for the lab. Okay.
Okay, so let's see. Okay, I just try to go through the review quickly, okay? Before we return to the theory RC circuitry. So that's just a very basic thing we want to go, okay? And if you're working on the left phone, then you will be get through it. Okay, let's see. You know, this is a DC level. If you're looking on your oscilloscope, then they just a straight line, okay? This is the time.
Mr. Pham,
Yes, sir.
We
Yes,
don't
ma'am.
have nothing.
we cannot see it.
Oh, I'm not there.
Yes.
Okay, just a minute. Okay, so this is in the left volt. When you're working on the left volt, you can be see again. So when you measure the DC voltage, okay, or the current, then you can see this will be a display on the time domain. That means on the oscilloscope. Then you see just a straight line, okay? And then if you're looking on oscilloscope for the sideway, then you can see this is a sideway here, and they can be keep going forever. And they will be telling you which one will be complete one cycle, okay? If you get any question, just stop me, okay? And in this waveform, the area triangle wave. In the waveform so, and AC or DC, which one?
Easy,
A, AC.
AC?
easy.
Yeah, they vary with the time. Okay, And now in here, current voltage level, they refer to the amplitude, okay? And they will be measured in volt. Okay, one complete repetition of a waveform we call a cycle. And the number of cycles that occur in 1 second that we call frequency, and the unit will be in hertz. So basically just a definition, okay, for a cycle and for the frequency. Okay, sometimes they can ask you what is the frequency, okay, and that will be just a number that occur in 1 second. This is a square wave. That this AC waveform display 4 complete cycle of a repeating pattern. Yes or no?
Repeating pattern.
How many cycles here?
3.
3. Okay. So not 4. So the answer will be no.
All right.
Okay. So in the DC circuit, opposition to the current flow is a resistance. In the AC circuit, opposition to the current flow is referred to the impedance. Okay. So in the AC, they're using the impedance. The thing is they will be combined of the resistor, they combine between the capacity reactance, HC, and also inductive reactance, HL. Combine it, they call impedance. Okay, the sine will be a direct relation to circulate rotation, like a circle. It divided into 360 degrees. Okay, so basically you can get this at a half. Okay, and they can go maximum 360 degrees for completely cycle. Okay, in a circle, one complete circle of the sideway equal 360 degrees. 1/4 of a cycle is how many?
90,
That will be 90. 300 divided to 4. Okay. In a circle, one complete circle in a sideway equal. That's what the answer 90. Okay, now this is a sideway. Okay. If you're working on the oscilloscope, that's what they display. If they want to know the volt peak to peak, how do we get the volt peak to peak of this sideway? Basically, on oscilloscope, analog scope or digital scope, they get the same thing. That means from the bottom up to the top, how many divisions? 1, 2, 3, 4, 5, 6, 7, 8. They also the same, any scope. So that is a H1 will be a division for the voltage. And also from the left to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 division for the time. So if they asking you how many voltage for the peak to peak means from here to here, then you have to counting how many division. 1, 2, 3, 4, 5, 6 division. And basically, how many they set it up for 1 per division? See in here, they say they want 1 volt per division. So you get 6 division. So that's why we peak to peak will be 6 volt.
Mr. Pham, for the frequency, you said that there were 9, but there's actually 7 for the time.
How many division for the time?
7, not 9.
I think that the total it will be 10. You're counting from here up to here. Is it 10 division, right?
Yes.
So,
For the time period.
no,
of
no,
this-
no. I'm not talking about that yet. I'm talking about general. Any oscilloscope,
He's just,
any general oscilloscope, they follow the same. Bottom up to the top, 8 division. Left to the right, 10 division. I'm not talking about the period and anything else.
Okay, good.
Okay, now you know how to get your V peak to peak. The thing is when you come going back to the lab on September, that's what you have to working on the oscilloscope. If you want V peak to peak, you can count how many divisions. Multiply by whatever you set it up, 1 volt, 2 volt, or whatever per division. Then you multiply by that division, you can get a peak to peak. After you get a V peak to peak, then they can asking for VIMS. Then you have to using the formula, 0.707 times V peak, or sometimes V average, they get a formula, okay? However, in the digital lab, digital oscilloscope in the lab, we get right now, if you want the VIMS, they can give it to you, okay? They don't already calculate it. And now, if you want to calculate the period, that means when the signal tries to repeat it, you start from here, going up, keep going down. When you're going up the same, okay, at going up here, that's a complete 1 cycle. And now you have to calculate to see how many division per cycle. So you can say 1, 2, 3, 4, 5, 6. So you get a 50% here, 50% here. That means the total will be 7 division. And each division you set for 1 millisecond. So the period will be 7 milliseconds. And if you want to get the frequency, you have to using F equal 1 over T. And that given you 142.8 Hertz. Again, when you're working on the lab, we get a digital lab, oscilloscope. You want frequency, they telling you what frequency. Then you don't have to using the formula to do the calculation. But the basic, you must be using the formula. Okay, any question? Try to really understand what on the oscilloscope. That will be help a lot when you start doing your real lab.
Mr. Pham,
Yeah,
a student typed in the chat that they're trying to get into the Zoom session and wanted to know if you would let them in.
oh, okay. Let's see.
Can you repeat this display thing again, Professor?
Okay, now,
Thank you.
when you're working on the lab, okay, you connect the oscilloscope, and they will be displayed this sideways. When you're looking into this sideways here, what they want to know what is the V peak to peak of the signal. Okay, so you understand from the bottom here to the top, you get 8 division. That stands for voltage. So now, peak to peak, you start from here. Go into the top. You have to count it. 1, 2, 3, 4, 5, 6. 6 division. Okay? Then you're looking into your oscilloscope, they display 1 volt per division. So you take 1 times 6, then V peak to peak will be 6 volt. Any question how to get that?
Yes, I have one, teacher. This constant 0.707 and 0.6 is only for this waveform, right? For sin.
Yeah. Let's see. How come they not share? Okay. This is what they display. And the question is, tell me what we peak to peak of this signal. Okay. Then you basically, you must be, no, peak to peak means from the bottom here, go to the top, take how many division? 1, 2, 3, 4, 5, 6. 6 division. And you're looking in here. In your scope, how many volt they set for division. For example, 1 volt. Then 1 volt times 6, you get V peak to peak is 6 volt.
Mr. Pham,
Yeah,
so for example, if the voltage per division is 2, that means the answer will be 12 volt, right?
depend on what the setting you setting for. You
Okay.
setting 2, they set they will be 12.
Okay.
Okay, make sure it's clear for everyone. The thing that you will be hitting when you start doing your lab. Okay, after you get V peak to peak, then you can get a V peak, right? Just a half of the peak to peak. That means you get a 3 volt. And then also you're able to get VIMS or they want V average. They get the formula for you. Okay? And the next step, they want to know what is the period. The period will be measured between a repeated signal. You start here, go up, okay. Now you're looking on the signal where they go up again. They go up, they going down. Okay, this point they start going up again. That means they repeat it. So that will be a 1 cycle. And then on the left to the right, you get 10 division. Okay, and now you start counting. From here, you get 50% of the one display. Here, 1 division, 2, 3, 4, 5, 6. 6 and a half here. You get a total 7 division for the time. And now the time they set 1 millisecond. They're telling you 7 division time 1 millisecond, you get say 7 millisecond. And if you want the frequency, basically you get f equal 1 over t. You're doing calculation, you get 142.8 hertz. Okay. However, you're working on the lab, we're using a digital lab. They already, you want V peak to peak, they're telling you. You want VIMS, they already telling you. You don't have to do calculation. If you want period, they given you period. You want a frequency, they given you a frequency. Okay, but I go by the basic. Any question anymore?
It's okay.
Okay. Okay, on top AC pass through a capacitor. The capacitor creates opposition in the form of impedance. That means you understand the capacitor in the AC circuitry. They get the capacity reactant. IC equal 1 over 2 pi FC. This opposition to the current flow depends on the measure of the capacitance and the frequency applied. Okay, if the value capacitance increase, okay, opposition to the current flow decrease. As a result, total circuit current will be increased. The circuit current decrease when value of capacitance is reduced. Okay, now, if the frequency of the signal software changed from 5 kilohertz, circuit current could be increase, decrease, or remain the same. When you're changing the frequency, so IC will be go up or down.
Down.
Down. That means the impedance going down. The current will be going up. Okay? So they will be increased. Okay, decreasing the frequency of the signal applied to capacitor. You decrease the current. Has no effect. Increase the current. Decrease the impedance.
Decrease the current.
When you decrease the current, a frequency, that means IC will be going up, right?
Right.
So that means IC going up, that means impedance going up.
Is going up.
Current will be decreased. Okay, now, this is a display, very important for the AC signal. You understand we already done for the AC voltage and the current. First thing you must memorize, okay? In the AC, the current IC will be leading the voltage VC by 90 degrees, okay? If I'm looking here, you can see that stands for the current. They go into the 90 before that guy, okay? So that means current will be leading a voltage by 90 degrees. That's an important thing. Okay? capacitor allow DC current flow only while it is charging. When it is fully charged, only while it is discharging, while it is charging or discharging.
D. Option D.
A or B or C or D.
A.
You understand on the basically we learning. Capacitor will be DC blocking, AC coupling. What that mean? That means they not allow DC current to flow through the capacitor, but they allow AC signal pass through it.
Oh.
However, have to memorize one thing. That only happens when the capacitor is already full charge. Okay? If they not full charge, if they charging or discharging, they still allow the current flowing. So the answer here will be D. Okay? D, with why it's charging or discharging. A capacitor, block AC and path DC. Block DC, path AC. Which one?
B.
Answer will be B, right?
Yeah. B.
Block DC and path AC.
Yeah.
Okay, so thing I go through it, that's just a very, very basic thing. Anyone learning supposed to be answered right away. Okay,
Can you
capacitor.
go back to
C1.
that question again, Mr. Fan?
Oh, now what happened to that question?
I thought when the capacitor is full, it will block the AC.
Yeah, that's what they're talking about. They already full. So they already full. What happened? They block DC and
Okay.
they part AC. That is the correct answer. Okay.
All right.
Now, capacitor C1 is full charge. What is the voltage drop across R1? 0 or 50?
0.
0, I believe. That will be 0 volt. Okay, that and. Okay, so now I need to turn on my iPad. Okay, so I try to go over quickly, okay? The thing you understand is if you get a basic understand for the capacitor and the resistor circuitry, then later on you don't have much problem for the inductor and the resistor, okay? So this is the capacitor here, okay? They can be either non-polarity or polarity, okay? And the value, you already see that. Okay, and also we already go to the capacitor charging and discharging. Only thing I want to make sure you memorize for me. Time constant, R times C. In this formula, R have to be in ohm, C have to be in farad. That's the first thing. And the second thing is the definition for time constant. Okay? Time constant is the time for capacitor charging or discharging to 63.2% of the maximum value. And if after 5 time constant, capacitor must be full charge no matter what. Okay, so that will be displayed when you're looking on that one. I try understand this is the charging. Okay, and this will be the discharging. Okay, so okay, we don't doing any calculation. Now, capacitor in series. Okay, if they connect in series, they just opposite like resistance. If the series, then you're using the same formula. 1 over C, 1 over C2, so on. Opposite to the resistor. Okay, and when they parallel, add them up. Okay, and also if you get only 2 capacitor in the series, you can using this formula. C1 times C2 divide C1 plus C2. Okay, and we already calculate that thing. Okay, now capacitor current and voltage during charging. Okay, this is display the discharging. They start from here. Okay, and they connect to the ground. They discharging up until they get a 0. And this is a charging. They start at voltage 0 on the capacitor, and they keep charging up to the point they go to the steady. That means they equal the E voltage here, and no more charging. This is full charge. Capacitor voltage VC equal the power supply E when fully charging. Okay, so that basically just display for you. Complete one sideways cycle here. Okay, relation between the radian and the degree. Okay, pi over 2 equivalent 90 degrees. Pi will be 180. 2 pi and 360 degrees. Okay, that's just a reference. Now, this is important here. For the capacitor, when you get the AC circuitry, they create the just a minute. They create a resistance. However, they call a capacity reactant. Here, capacity reactant. And that calculated by the formula 1 over 2 pi FC. Okay, in this formula, pi 3.142. F have to be in Hertz, and C must be in Farad. Okay, the relation between the capacitor VC and the current IC. Okay, for pure capacity circuitry, current lead voltage by 90 degrees. Now, if you're looking in here, you can see this is the current and this is the voltage. Okay, current will be leading voltage by 90 degrees. That's a very important, and you must know. Okay, and in this one, we already go through it. That means they given you the circuitry and the value of the total voltage, frequency, capacitor, and they want to calculate IC. Okay, this one, you're just looking back and try to see how do we calculate with the unknown value when they given you some. And this is now when you get a capacitor connect in series. However, the value here is not the farad, microfarad, millifarad, but the display will be capacity reactant. That means in ohm. Then you want to calculate the total exactly like the resistor. Okay? Series you adding up parallel. You have to using formula. The same like the resistor. Remember, even either inductor or capacitor, when you get the ohm, then they working exactly just the resistor. Okay, and now on this one, first one here, try to understand, then you can do almost the quiz, almost the homework, everything. You get a circuitry with the AC circuit, AC voltage here, the capacitor and the resistor. Okay, and you know that the series circuitry, when they draw the current I total here, you see they get a two arrow. Why? The thing is AC. You cannot tell which side will be positive, which will be negative. They vary. Okay? So the current, the same thing, total current, or IC current, or IR current. That's only one current. Okay? In here, you can understand for the voltage VR across resistor, VR, IR will be in phase. Okay? They will be in phase. That means both going up, both going down. Okay? In phase. Resistance have a no phase different. Okay? However, you can get that one thing you know. That means the void VC right here and the IC here. IC will be leading VC 90 degrees. Okay? And only one thing we don't know. That means the voltage here and the total current here, they not in phase, but they not 90 degree different. They get some different, but not 90. Only thing is IC leading VC 90. Okay? So if you can read it, you can see IT the same in all. Voltage VR in phase, that means they try to explain to you one thing. That means the resistor and the IC, what the relation between resistor and IC, capacity reactant. And we already know resistor here will be leading the IC by 90 degrees. Okay, now if I draw the vector for R this way, okay, then how come I draw the vector for the IC? You understand that when you're going up, that means 90 degrees. Then you're going down, minus 90 degrees. So R will be leading IC 90. So I draw R this way. Then IC must be going down, not up. Okay? And now you can able to get the phasor. You draw R here and you draw IC going down. Okay? So this is a triangle. Okay? And basically this is the IC, the total impedance. So if you're using the Pythagoras, you can calculate IC equals square root R square plus IC square. That's only telling you one thing. Why did the 80 ohm and make it 60 ohm, and we cannot adding to get a total. For the people understanding, then you must say the thing is resistor and the IC, they not in phase. So that's why you must be using G total equals square root R square plus IC square. That's what we're going from this one. By the way, I already telling you, if you want to calculate the sine of the angle here, they will be IC divided to Z total. Or cosine of this one will be R divided Z total. Or if you get a tan of the theta here, will be equal, okay, minus IC over R. That's just a very, very basically, we don't want to go into too much trigonometry, okay? And now, what they want to do calculation, they doing calculation the total XT. That's what you're using this formula. If they want to calculate the IT will be equal VT divided to Z total. If you want VR, and VR equal IT times R, VC will be IT times HC. And now they want to know what the phase angle here. They will be equal minus HC divided to R. If you want to get the angle using 10 minus 1, okay, for this problem here, we calculate, we get minus 53.13 degrees. Okay, so what is the phase angle? Minus 53.33 13 degrees. What is that angle? The thing is, sometimes they can ask you, what is that angle for?
53.
Who can tell me? When you're talking about IC, VC, you know, IC leading, VC 90 degrees. If they're talking about resistance, then R and the voltage VR are current IR will be in phase. They have a no phase.
Yeah.
So what is the phase angle? Minus 53.13 degrees. That is only the phase of the voltage, total voltage, and the total current. The thing in here, you know VR, IR. They in phase. You know IC, VC, different 90 degrees. However, V total and I total, they not in phase, but they not 90 degree different.
Yeah.
So they will be different by 53,
50.
minus 53.13. And they're telling me the current, total current will be a leading total voltage by 53.13 degrees. Okay, try to understand it as a way to basic solving the problem. Okay, after you go to RC series parallel, RL series parallel, RCL series parallel, and now we're going back with a different way to solving AC problem using the complex number. Okay, in a complex number, you don't have to calculate the phase angle. The thing is, complex number, we're telling you right away. Okay, up to this point, you get any question on the RC series circuit?
Yeah, I have a question. So BT is not equal to BR plus BC divided, right? Because it's not in series. The total voltage BT is not equal to voltage in the resistor plus voltage in a capacitor.
You're talking about VC or VR, right?
Yeah.
Okay, now VC, that's the voltage across the capacitor. Okay. And VR means the voltage across the resistor. They're not in phase. They're
So
not
it's not
90
equal
degrees.
to BT is not equal to BT.
What's wrong with VC?
BT is not equal to BR plus BC, right?
You're talking about VR plus VC, right?
Yeah.
So what that mean? What is,
Then
they not equal that one.
this one, BT.
They not equal VT.
All right. Yeah, the sum of BR plus BC is not BT.
Right. It's not. Why? The thing is they're not in phase.
Because
So
it's
if
not
you want to get, if you want to equal VT, then you have to using the formula. Square root of VC square plus VR square. Then
Okay.
they will be equal to VT.
Okay.
Okay? The thing is they're not the same phase. Then you cannot say you adding VC to VR. They suppose you have to be equal VT. Okay? But I said they not the same phase.
Okay.
So if you want to calculate the total VR and VC, you must be using the formula. VT equal square root. I given you here. Okay. VT have to be square root VC square. VR square. Okay.
Exactly. Yeah.
Thing is they're not in phase. Okay. Any other question? I said guarantee. When I given you that problem, you're able to doing or not the calculation. Okay, now this is the one you're supposed to do to make sure, okay, you can get the answer. Okay, this is the answer I already given to you for you to try. Otherwise, we don't have much time. Okay, and also this is another example. Okay, if you can go through those examples without looking into any more formula, then you're okay. Now I'm talking about that one. We try to finish that one. So next meeting we go into RL circuitry. Okay, XC and R in parallel. Okay, the voltage VT is the same. The known component. You understand voltage here? VC, VR, and VT, only one voltage. The plane current I to R in phase with VT. Okay, the thing is why they said current I through the R in phase with the voltage here. How? Who can answer for me?
Because it's a resistor.
How come they said current I to resistor in phase with VT? I want you to tell me how. Okay, so if you not said anything, I can tell you. VT right here. VR right here. VT and VR. What happened? VT, VR equal VC. Is that right?
Yep. No. Yep.
Yeah, you get only one volt.
Yep. It's in parallel.
Okay. Now, the current IR. Okay. IR and VR in phase or 90 degree or out of phase. Which one?
Phase.
In phase, right? IR, VR in phase. And VT, VR the same. So that's why they here, they say I through R. They will be in phase with VT. Can you follow that? IR in phase with VR. VR, VT will be the same. So that's why they say IR in phase with VT.
Yep.
Okay?
Yep.
Okay. Now, I see lead what? I see lead what?
Voltage.
V.
DR. BC.
That is the formula. I see lead VC. No
Yeah.
matter circuitry, I don't care.
Yeah.
Okay. So now they say I see lead IR. I see lead VC. And also I see lead VT. Right? VT or VC, the same thing. I see lead VT, and we just say IR and VT in phase. So that's why they come up with here. I see lead IR. Can you follow that?
Yep.
Okay. Now, you can try to understand when we draw the vector here. That's a 0. And normally they want to draw R or VR. They draw this way. I think that they have a no degree. Okay, so this is the IR. How come you draw for IC? Up or down?
Down.
Down.
They say IC lead VC 90. Lead, that means they have to go up. They have to be IC here. They lead in 90. If they lagging, if IR lead IC, then IR here, IC have to be going down. Like we already know. You draw R here. You want to draw IC. We already are leading IC 90 degrees. So IC have to be going down.
Okay.
Okay? Make sure you can follow that.
Yeah.
Okay, the current I through C lead VT by 90 degrees. Okay, let's see. Now, first thing, if you want to calculate the IC, that is easy. V total divide HC. Calculate IR will be VT divide R. However, if you calculate the total current here in the basic DC circuitry, then IT equal I1 plus I2. However, in this circuitry here, they're not in phase. So you want to calculate the IT, you have to using square root IR square plus IC square.
Right, like Pythagoras. Yeah.
Okay? And if you got calculate the total impedance, you take the total voltage divide total current. And also one thing you need to do is calculate the phase angle. So the tan theta here will be equal to IC divide IR. If you want to calculate the angle, tan minus 1 IC divide IR. That's all of the formula you must know in order to get through this circuitry here. Okay, and this one we already calculated for you. Okay, you must be trying to do over how to calculate the IC, IR, IT in total impedance and the phase angle. Okay, and the second example here also. Okay, that's it. Any more questions? Anything else?
Okay.
Okay, so the thing is the next quiz will be on Wednesday. We'll be using on AC here. That means you have to deal with the AC circuitry, RC series, RC parallel, and anything regarding into capacitor, okay, in the AC circuitry, okay? That's only thing I expect you to get through it, okay, and you're able to get the A in the quiz. And you can see in the past, okay, the first time you learning, maybe you not quite understand. However, the second time you get through it, you get much better. And the thing will be online. So that's why we have to repeat it. I try to make sure you guys can get a basic understanding in electronics. You can do a very good technician job, or you can go to the college, university. That will be help you a lot. Okay. So if you guys don't have any more questions, make sure you give a name for Sam. So he have to record in the lab phone time. Okay. Then that's why I know how to schedule for you guys when we start on the phone. Okay. So now, okay, we'll be stop here.
Okay, thank you so much.
Okay, you are welcome.
Good night, Mr. Pham.
Yeah, good night. Good night, everyone.
Uh,
Yeah, Mr. Bennett, thank you.